All right, here is the second LeetCode problem of the day. This one is squares of a sorted array. So it says given an integer array called nums, it's sorted in non-decreasing order. You want to return an array of the squares of each numbers and keep it sorted in non-decreasing order. So for example, we have -4, -1, 0, 3, 10. So what we have to do is square each one. So -4 squared would give you 16. 100 squared, 10 squared to give you what, 100. So you have 100, 16. 3 squared would give you that 9. -1 squared would give you 1. And then 0 squared to give you 0. But the thing is that they need to stay in order. This is already in order. But once you square it, it's going to not be in order, only because -4 squared is going to be 16, and so that is definitely greater than this 1. So it just talks about here after the square and the array. This is what the array becomes. Yeah, just like I said. So -4 becomes 16. 1, 1, 0. So then it needs to be sorted. And I'm not sure if you can just do the array and sort it. I never tried that, but I'm just going to do it a different way. And it's the same way here. So -7, I think it says down here, squaring each element and sorting a new array is trivial. Could you find the old? Yep. So like we're not going to do this. We're not going to do this like, because that's easy to just, like it just said, it was trivial to just square each one, put it in an array, and then sort this array. So we'll do it in O of n time. Anyway, so the second one is -7, -3. So -7 give you that 49. So of course this needs to move over here because we need to keep it in non-decreasing order. Non-decreasing order or increasing order. So what we're going to do is we're going to use two pointers technique to do this. So what I'm going to do is have 2 pointers and actually a writer. So I'm going to have 2 reader pointers at the end. One pointer right here, one pointer right here, and then I'm going to have a writer pointer that points to a new array starting from the right. And then I'm going to compare this pointer with this pointer squared, and whichever is greater, that's going to go here. And then this gets decreased. The greater one gets decreased, and then it goes again. Whichever one is greater, we're going squared. We're going to take that one and put it into a new array, and that will give us our array. So we're doing a backwards fill. And another thing is we're taking I'm going to take the absolute value of this. I'm going to compare the absolute value of it, because if I compare -4 to 10, well, let's do -4 to 3. If I was to compare those two, the greater one would be 3, unless we take the absolute value. So that's the algorithm I'm going to do. So here's the implementation. So like I said, I'm going to have we're going to do 2 pointers, but I'm going to have a left pointer, which I'm going to call the left reader. That's going to equal 0. Then I'm going to have a right reader. That's going to also not equal 0. That's actually going to equal the end of the array. So we'll put that in nums.length -1, and that puts that at the end of the array. And then, like I said, I'm going to have a new array that we're going to use to put to order everything. So this new array is going to be int. We'll call this res for the new array, the result. And that's going to equal new int array. It's going to be nums.length, and this is going to be an int array data structure. So it's an array data structure. Let's see. Okay, so now we have our new array right here. We have the left reader, which is going to read from the left. We have the right reader, which is going to read from the right. And then I also want a writer, which is going to be a pointer that we're going to have inside this new array. So we're going to do int and I'm just going to have this as a writer pointer. We'll just call it a writer. And that's going to be at the end. So that's going to be at res.length -1, putting that at the end of the new array. All right, so now that we have that, so now we can do what do we want to do? We want to we want to start comparing. So I want to compare the left reader with the right reader, see which one is greater, and put the greater one in the new res array at the end. So what we're going to do is we're going to iterate through the array. Nope, we're not going to iterate through the array. So we need to do a while loop while the left is greater than, well, while the left side is less than or equal to the right side, we're going to continue. Because left starts here, right starts here. Once we figure out which one's greater, we're going to move the left, move the right, move the left, move the right. And once they're equal to each other, that's when we're going to stop. So that's the stopping condition. So we're going to do while left reader is less than or equal to right reader. And we want to do equal to because in a case like this where they meet in the middle, that's when we're going to stop. Left reader is less than or equal to right reader. And then now we're going to compare them. So we're going to say if nums at left reader is greater than actually, yeah, that's what we want to do. Nums dot, but also want to take the absolute value of that as I'm comparing it. So I'm comparing math dot abs absolute value of nums at the left reader. So if math dot absolute value is on the left side, if the left side is greater than the math dot absolute value of nums right reader, so if math dot absolute value is greater than than the right reader, so we're looking at both ends. If this one is greater than that one, then, or if the left is greater than the right one, then we want to take that res, which is that new array, and put it at that writer position. What are we doing? So we're going to get the greater one, which is the left one. The writer position is at the end. So what are we doing? We need to put this at the end of res. So, but how do we point to the end? Res.length. So writer is pointing to the end of it right now. Oh yeah, so writer is pointing to the end of res right now. So then we can just put res is equal to, res at the writer is equal to the greater one, which would be left, but we need to do the square of it. So we do nums at left reader, multiply that by nums at left reader, and that squares it, puts it at the end because writer is at the end, so it puts it at that spot. And then we want to increase the left reader pointer to increment, and then, oh, why is that like that? It's too many. Okay, that fixed it. So left reader goes up, and then we'll do the else case. Else res at writer is equal to nums at right reader times nums at right reader, and then we'll decrement the right side, right reader minus minus, and then we also have to decrement writer, because each time writer needs to go to the next spot to put the either the left side or the right side. So let me just go through. Oh, we need to return that array, which is res. So just going through this really quick. I didn't have a timer on. So we're going through it. Like I said, we're creating this new array. The left side is going to be 0, the left pointer. The right pointer is going to be the end of that array. The writer is going to be at the end of the new array. And then we're going, as long as left reader is less than or equal to right reader, we're going to look at the absolute value of the number at left reader, compare it to the right reader, this absolute value, and whichever one is greater, then we're going to put that in the end of the new array where the writer spot is, and we're taking the squared of that, increasing the left side. Otherwise, we're going to do the same thing, but to the right side, decrementing the right side. Writer is decrementing, and we're returning. So that should be okay. Okay, I removed too many parentheses. So it's if math is greater than, I don't need this one right here. So that means I don't need that one there. Just put this one at the end. All right, so this parenthesis goes with that one. This parenthesis goes with this one. Hopefully that's good. All right, so we passed our test cases. We'll go ahead and submit that. And we're good to go. Beats 99.891 milliseconds on runtime and 75 on memory.